All right, so now we're going to learn about positional systems. So our current system called the Hindu-Arabic num- numeral system is an example of a positional numeral system with base 10. In a positional system, the value of each symbol depends on its position within a number. In such a system, a base is selected. There would be a certain amount of symbols corresponding with the base that's selected. This is all kind of general speak. We'll see it more when we get into bases that aren't base 10. So for now, it's going to seem very convoluted is not the right word, but it's not going to seem very useful. Not going to make a whole heck of a lot of sense, but when we incorporate other systems, you'll see. All right, but the idea behind this is that if we have a base 10 system, then we would have nine. So going from 1 to 9 plus the 0, which would give us 10 digits. All right, and again, the whole digit concept comes from, or at least the base 10 part of it is the 10 fingers, so it's easy enough to count. But yeah, a lot of this expansion here, not going to mean much just yet, but really what it comes down to this, and we talk about exponentiation, but really it's just a matter of saying that if I have 7,803, that's the same as saying 7,000 plus 800 plus 3. And we would think of that as 7 1,000s plus 8 100s plus 0 10s and then plus 3 1s. All right. But we could also use exponentiation to write this as, instead of saying 1,000, I would say 10 to the third, 10 to the second for 100, 10 to the first for 10, and 10 to the 0th would give me a 1. And that gets generalized to some coefficient, whatever it happens to be. So here it was a 7, but we're saying some coefficient occupying the fourth position that corresponds with a power of 3 associated with whatever number of units are in your base system. So base 10 has 10 digits. If it were base 2, then that B value would be 2. And then we would work our way from left to right, and that would give us some way of expanding, or a reasonable way of expanding the numerical value. All right, the zero exponent rule. We've been kind of working with this a little bit indirectly, but it's any number raised to the power of 0 is going to be equal to 1. That's why I was saying things like, for example, 1 is the same as saying 10 to the 0th power. All right, which is stated right here. The examples of positional numeral systems, we have Chinese scientific. All right, that's the bamboo and counting rod approach. The Mayan system and the Babylonian cuneiform. All right, we'll start off with the Chinese scientific. We have a rod numeral system created about 2,000 years ago. Used bamboo rods to represent numbers. That's where it gets its name. The idea is that without having pencil and paper, you could carry around rods and use those. I mean, they don't have to be overly large, but basically you're counting sticks in order to determine numerical values. And if you have certain arrangements of them, that would correspond to certain numerical values. All right, but the way they did it was they broke it up into horizontal sets and vertical sets. In terms of a place values, let's say, for example, I have I'll use that same number, 7,803. All right. we have a thousands place, we have a hundreds place, a tens place, and a ones place. All right. So in this the thousands place we have a 7, in the hundreds we have an 8, in the tens we have a 0, and in the ones we had a 3. All right, what this numerical system would do is it would break up the place values based off of horizontal and verticals, but that would correspond to different places within the 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 the, the numeral, so digit by digit. All right, so the units place or the ones place, it would be every other. So ones followed by hundreds, and then if we went further, it would be 10,000s and so on. That would be the set of verticals. So we start off, if we're going from right to left, so the opposite of what we would normally do. So we go from right to left instead of left to right. We would start off with vertical and alternate every other place until we complete the entire number. Then for the second digit, alternating also, those would correspond to horizontal values. So there's a set of numerical values, 0 through 9, but depending on whether it was occupying the ones, hundreds, 10,000s place versus the tens, thousands, 100,000s, and so on, those places, they would be organized either vertically or horizontally. All right. So the way I would evaluate 7,803, all right, so all of this is really just going to address that, but I'll do it right here. Right. So I have the thousands place, which goes into my horizontal category. Right. So I would look for the 7 in the thousands place, but that's reading it from left to right. But if we want to be kind of consistent with the way it should be done, we really should be reading it from right to left. So I'd start with my ones place, which would be a vertical 3, and so we're counting with sticks, and if sticks are straight, I'll say line segments, if you will, but really if you think about like a straight stick, if you're carrying around a bunch of sticks, like pickup sticks or pencils or whatever, really your choices are to organize them vertically, horizontally. I mean, you could do it diagonally, but that wouldn't really have much meaning in this case. Right? So for 3 sticks, it's just a question of whether it's going to be horizontally organized or vertically organized. All right, so we start off with vertically. All right, the ones place are our vertical cases. So 1, 2, 3. That would account for the 3. So if I were to do tally marks, like if I were creating a histogram or doing something where I'm just keeping track of the number of items in one category or another, I might use tally marks. Right? The old movies where the person's stuck in prison and they're counting the days. What do? They scrape little tally marks on the wall. All right, that would be the case of, in this case, the ones position. So up to 5 is where we'd have just those vertical tally marks, right? So that accounts for that first number. The tens place doesn't have a number, right? In our 4-digit number 7803, we used the 0, but in the Chinese scientific, there was no 0, so they just left a space, right? So then we'd move on to the hundreds. We have an 8 occupying the hundreds position. So that would look like that, 3 verticals and a horizontal slash, all right? And for the thousands position, all right, so we're back to being we actually never did horizontal because that's what this open space here was, right? That should have been a horizontal number. If it were anything other than 0, it would have been, right? But we left a little space there for that. But the 7 is going to be a horizontal 7, so that's going to be 1, 2 with a 1. All right. So these 4 values, all right, 1, 2, then the missing one, 4, that equates to 7,803. All right. Identifying whether your number is of a vertical type or a horizontal type is really just as simple as looking at the diagram. Yeah, there's some that have vertical and horizontal, but in the case of horizontal, you would see that in most cases there's more horizontal line segments than there are vertical ones. Right. The exception would be 6. Right. So as long as you can kind of keep that straight, everything else kind of works itself out. But that's really it. This is the number here, right? Including that space, right? So if I were doing 27 in Chinese scientific, so my ones place, right? Again, we start vertical, and what I like to do is just do a V and an H, all right, working from right to left, just to kind of remind myself, all right, this is from the vertical set, this is from the horizontal set. And that's not to say that I have any of this memorized. It's really just I want to know where in the table to look for the correct information. So in my vertical list, I'm looking for the 7, all right? So that's the one that kind of looks like a pie, all right? And then for the 2, I'm looking for 2 in my horizontal list. That's the one that looks like an equal sign. And that's really all there is to it. Right. So in the case of example 2, again, we start vertical, horizontal, vertical, horizontal. All right to left. I'm looking for a vertical 8. All right. So that corresponds with this. Then a horizontal 6. That's the upside down T. Then a vertical 5. So that's 5 tick marks. And then a horizontal 8, which is the symbol here. All right. And personally, I mean, because 0 really hadn't been invented yet, or the concept of nothingness was not something that needed to be invented. It was more like were people using a symbol to represent 0, and so far not. So, but what people will do sometimes, they'll put like a 0 placeholder in there. But really, the correct way of writing it would be without that 0, that space left. The other thing, and it's written in here somewhere, I forget where, but the other thing would be a little shorthand way of writing it. Oh, I wrote it down here. Is to write it without the space. So 7,042 would, if I wrote it without the space, it would look like a 3-digit number. But because we have a vertical, horizontal, horizontal, what that means is that there's an implied vertical in between. All right. So even though it's not there, if I know that I have 2 horizontals and I know that they're going to alternate vertical, horizontal, then there must be a vertical in here. And since there's nothing there that's vertical, it must be nothing. It must be 0. All right. So let's see. Do I have an example there? Let me just make up one real quick. So let's say, for example, I'm going to do that, then let me do this, and this. All right. So if I needed to translate this over, all right, so I guess I could do this example first, but it really doesn't matter. You know what? Let me hang on to this side example for a second. I'll do the one that's on paper. So first off, we're looking at vertical, horizontal, vertical, horizontal, vertical. So we don't have any issues there in terms of placeholders. So now it's just a matter of matching it up. So we have an 8. In my horizontal list, I'm looking at a 7. In my vertical list, I have a 2. In my horizontal list, I have a 6. In my vertical list, I have a 3. Right, so that gives us this number working right to left again. Right, but let me do my example here where I have, and I purposely made it maybe a little trickier. We have a vertical, a horizontal, and a horizontal. All right, so my vertical with the 4 vertical line segments would be equivalent to a 9. All right, then I have my 7. Then I have I have a 7. This one is organized horizontally, but it's still a 7. And then the 1, all right? But because there needs to be that alternating component, there must be a horizontal in here, vertical, horizontal, vertical, horizontal. There must be a vertical here also, all right? So in terms of my placeholders, I'm going to have the 9, 0, 7, 7, 0, 1. All right, and that lines up with the units place being vertical. All right, so my units, my ones place, my hundreds place, not my thousand, but my 10,000s place. Those are all my verticals. My horizontals are pretty much everything else. All right, so I got a tens place, a thousands place, and a 100,000 place. All right. Then example 5, same idea. Look at what you have. All right. So that that symbol on the right hand side, the little equal with the vertical on it, that's a 7, but that's a horizontal. So we have a horizontal, vertical, horizontal. The issue here is we need to start off with a vertical. So that means since there's nothing there, that must be a placeholder. All right. So I have a 0 here, a 7, a 1, and a 4. All right. We could also do computations. All right. The computations aren't really that crazy as long as you can match up the different places. All right. What I like to do is, depending on how it's presented to me, I might rewrite it just so I have my places matched up. But I have a vertical, which is what I should have, horizontal, vertical, horizontal. So that's set up nicely. That 0 is kind of like a placeholder to. It wouldn't be something that would actually be written there, but just for the sake of it being a little bit more obvious, it's there. But you know what? I'm going to just take it out and pretend it wasn't. All right. So what we would have here is vertical, vertical. All right. So if I'm matching up 1, 2, 3 and a 1, 2, that's going to give me 1, 2, 3, 4, 5. All right. Then I'm matching up my 7 with nothing. So that's going to get me a 7. All right. So again, because we have that horizontal here that didn't have any information provided. All right. The next one, I have a vertical 1 and a 1, 2, 3, 4, I think it's 5. But when I put those together, I get 6. All right, so 6 is that upside down T. All right. Depending on the placeholder, though, so I got to be careful about that. Upside down T, if it's horizontal placeholder, this is actually vertical placeholder. All right, because it's vertical, horizontal, vertical. So that's going to be just an ordinary T looking figure. All right, so one thing to be careful about. And then back to horizontal. Now these are, not to be too confusing here, but these are attempts to write like when you do addition, where you do like a this plus this. So what I'll do is I'll just kind of use our standard notation here. I just want to make it a little bit more obvious, because it's like, well, where do these new horizontal lines come from? We're back to the horizontal placeholder. I have that horizontal. There's nothing here, nothing here. So I could even say in that horizontal position, there's nothing. So it would be just this. All right. And so, I mean, doing something that's done, but, just so you have it. It's one thing to see it written, but to see how it was actually generated is obviously useful in some cases. And I don't have any delusions that you're going to sit and watch every single video that I make and do it at ordinary speed. You're going to hop around as needed. There are going to be some things in the notes where you look at it and say, well, this makes sense. I don't need a video for it. And then there's going to be other things where you'll be like, okay, I don't quite get this one. And that's when you come to the video. So hopefully these kind of explanations help. But if not, that's fine too. That's the way of things online. All right. So yeah. So now you should be good to go for exercise set 141.